a plane is bearing, or let's say is heading northwest at 220 miles per hour, encounters a wind due east at 10 miles per hour. Let's find the new bearing. Now we're going to talk about bearing in a minute. Pilots and navigators, people who navigate on the sea, they use weird conventions for figuring out directions instead of like if we have north, south, east, west. That when we use the word bearing, that's relative to due north. So the way that works is due north is 0 degrees. And they rotate around clockwise. So this would be 90 degrees, 180 degrees. A bearing of 180 degrees means you're moving due south, 270 degrees, and so forth. So if you ever hear somebody has a bearing of 110 degrees, that means they're going this way, 110 clockwise from due north. So they would be going kind of southeast-ish. Okay, so we'll figure that out once we get our direction. All right, let's draw this out. So my plane was going straight northwest. That's here. That's a halfway between north and west. So that's a 45-degree angle. It was trying to go at 220. That will be the magnitude of my vector. I need to find his x component. Let's call him the vector p for a plane. Here's his x component, and here's his y component. And then I had my wind vector. It was blowing straight east, so he doesn't have a y component. Here's my wind vector. He'll be easy. His y component is 0 because he's just going in the x. And his x component was 10. Okay, we need to break the plane vector up into components. So we use trig. So the x component here, px, will be magnitude of the vector times sine or cosine, because it's adjacent to the 45. And py will be magnitude sine of 45. Now I have to be careful. I have to put in the pluses and minuses myself. So I can look at the picture and see that this x component is negative, this y component is positive. So this would be 220 cos of 45, negative 220 sine of 45. Oh, no, that one was the negative. This is positive, sine of 45. All right, so I'm going to type both of those into my calculator. I get 155.56 for both, but the first one's negative. Remember this x component, look at the picture, is negative. So my plane vector written in component form is negative 155.56, comma 155.56. Now my net velocity vector in miles per hour, the resultant vector, add the x's, plus 10, comma, add the y's. So that's negative 1, I can do that in my head, comma 155.56. Okay, so there's my velocity vector. My units are miles per hour. Now I want to find the speed. Speed is the magnitude of velocity. So I need to do some Pythagorean here. Okay, let's draw this guy out first, by the way. He's got a negative x, a really big negative x, and a negative y. He's going like this. There's my velocity vector. So his magnitude, my speed, will be square root of the x squared plus the y squared. This is the only time I would ever say this to you. I want you to ignore the negative. When finding magnitude, ignore the negative, because I know what happens. You guys type this into your calculator. You type that in and you're going to get the wrong answer, because that's not what you should be typing. You should be typing this. It's the x component squared, so you have to square that negative. But what happens when you square a negative? It becomes positive, so forget about the negative. It plays no role in magnitude. Ignore negatives when finding magnitude. Don't worry about that negative. It's going to get squared away anyways. All right, so let me type that in. So that's square root 145.56 squared plus 155.6 squared. 213. 0.04 miles per hour. There's my net speed. That's how fast the plane will end up moving. Notice that is slightly less than it wanted to be moving because the wind is stealing some of its speed. It's stealing some of the x component of the speed. Okay, now let's find our direction. So here, let's draw out our vector. If you're not sure what to do, anytime in a trig class, if you're like, I wonder what I should do next, draw the triangle is usually the right answer. So this was a negative 145. This was a 155. Let's say we want to find this angle there. Let's say I write this. Tangent of theta is opposite over adjacent. Okay, so I'm going to type that in my calculator. This is a true statement, by the way. I haven't lied to you. And then let's say you do theta is the inverse tangent of that. Well, now I've lied to you. This statement is not true. This one is, this one's not. Remember, this is not really inverse tangent. This is only inverse tangent in quadrants 1 and 2. Quadrants 1 and 4. We're in quadrant 2. My calculator is going to lie to me here. 50% of the time, your calculator is a liar when using inverse trig functions. So I'm going to type that in. Here, I'll pull up the screen. So I'm doing inverse tangent of 155.56 divided by negative 145.56. I get negative 46.9 degrees. I'm going to write that down, but that is not the right answer. I don't remember what I said, 46.9. That is this angle. Your calculator for inverse tangent will always spit out angles in quadrant 1 or 2. This is negative 46. That's not, we're heading that way, not this way. Your calculator is a liar. I need to add 180 to that to get that angle. So I'm going to do that. Plus 180. 133. That would be, this is 133. That's just a weird way to measure the angle. Remember, when it comes to direction, there are an infinite number of ways to give direction. when it comes to direction, as long as you say from something that's a fixed direction, you're okay. So what I'm going to do is forget about all these negatives. This is a 46.9 degree angle right here. So that's 46.9 degrees right there. I'm going to say, here's one way we could give the answer. 46.9 degrees north of due west. Here's due west. I've rotated 46.9 degrees toward the north. One way we can write that is west 46.9 north. So it says go west, face west, rotate 46 toward the north. So that's one way to write that. Or we could give this angle here, right there, which would be, what is that, 43.1 degrees? From north toward the west. It's another correct answer here. There are an infinite number of ways to give direction here. So I could say this is also direction, 43.1 degrees west of north. Perfectly fine. Or if I wanted to give bearing, remember that's what the question asked, that would be trying to measure this angle all the way around. So 0 degrees is straight north. This would be 180, 270, plus another 46. So if I wanted to give bearing, that would be almost all the way around. I could do 360 minus that 43, or I'm going to do, there's 270 plus an extra 46. So I don't want to do that in my head. I probably could. But 270 plus 46.9, 316.9. That's the bearing. And that's the way pilots think. If you tell them your final direction is going to be a bearing of 316.9, they would understand that. Now, on the written assignments, I don't care which one you give, any of these. This one, by the way, could have also been written north 43.1 degrees west. That's west of north. You could write it out in words. We had that, what was 131? If you wanted to give that angle, you could say 130, whatever that angle was, 133 degrees, I guess, counterclockwise from due east. It would be a weird way to say it, but that would be acceptable. There are a lot of different ways to write out the direction. Don't forget this part though. Speed, 213 miles per hour. Don't forget your units there.